In a world where up to 85% of textiles produced per year end up in landfills, the fashion industry emits around 2.1 billion tons of carbon dioxide, and greenhouse gas emissions are predicted to surge by more than 50% by 2030. We can do better. Introducing SynthEthics, an environmentally conscious app that accompanies users through the life cycle of an item of clothing, from acquisition to use, and ultimately disposal. We aim to raise consumer awareness on their buying patterns and encourage a more sustainable use of clothing. Welcome to SynthEthics.
Hi, I'm Roy.
Hi, I'm Tommy.
I'm Jin.
I'm Emily.
Aki.
And I'm Divya.
And this is SynthEthics, an automatic carbon footprint calculator.
So what is the carbon footprint aspect of our app? We created Karma Points as a way to provide an estimate of the carbon footprint incurred by purchasing an item of clothing. You may think of it as a sort of carbon debt incurred by the user that can be paid off partially by wearing the clothing item or donating it. Karma Points are defined as a sum of three factors: the carbon emissions from producing the clothing materials, from the transportation of the clothing item from its origin to the user's location, and from the manufacturing process. When looking at the clothing materials, a material that creates more environmental pollution during its production, such as polyester or leather, would generate a higher karma value than less polluting materials such as bamboo or linen. We calculate an estimate of the carbon emissions from transportation using the shipping distance in kilometers from the origin to the user's country. The shipping distances are obtained from common shipping routes between locations, and we also make the assumption that clothing is primarily transported by sea. The combination of these three components are then weighted by the clothing category. For example, a top would be weighted less than outerwear.
We will now demonstrate our application from the perspective of a new user. This is the homepage where we can see a summary of all our usage stats, and this will be populated further as we use our application. So let's get started by adding an item of clothing to our closet by clicking on the Add Item button in the middle of the nav bar. We first need a picture of the item's clothing label. We can either take a photo or select an existing picture from our gallery. So in this instance, we'll be taking a picture of the clothing label. I have my item of clothing here and the clothing label. So we can take a picture and select that. Yes. Once we have selected a picture, the application will attempt to recognize the item's place of origin and material from the clothing label. As you can see here, it is accurate to our clothing label from earlier, but if they're not, we can still manually input them as necessary. We then need to input the item's clothing type. Now we can check this into a category. I think this classifies more as an item of outerwear, so we will select that. The application will call our calculator, and this will return a karma value for this item of clothing. So we can use this feature whilst browsing. We will then proceed with adding this item to our closet by clicking next, and we can add a thumbnail for this item of clothing. In this instance, we will then select from our gallery, and this thumbnail will act as the representative of our item of clothing within our application. So when we go to the closet later on, you will see that this thumbnail represents the clothing visually. So we will go on with adding that. Now that it's added to our application, we can give this item of clothing a name. Let's say this is a black jacket. We can give it a brand. We will go ahead and do that. The color category down here, which is automatically detected from our thumbnail, and this is for use in outfit generation later on. We'll go into a bit more detail. So we can save this item to our closet. And as you can see here, the items bought has now been incremented.
We can now go to the closet to view our newly added item. Our items are organized into separate categories. As you can see, our newly added item is right there. We can select it and open up a more detailed view of it. This will show the number of times we can wear it to gain karma points. If for the day we decide to wear this item, we can do so by clicking wear. We also have the option of undoing it in case of mistakes. Once we have worn an item of clothing, we can see its progress bar increases. Our own total karma points also increases, and this is shown here in the personal dashboard. We can see the graph records our activity has on a daily, monthly, and yearly basis. And our karma graph helps engage users in keeping track of their progress. Another way we achieve engagement of users is through user achievements. We currently have two achievement types. The first type is one-off unlockables, and the second are tiered achievements which can be leveled up by increasing our stats such as karma points. For example, since we have just gained some karma points, our achievement for total karma points has progressed, and we now only need 60 more to reach the next level. One-off achievements are grayed out until unlocked, as you can see. In case our app is a little too much for new users, we've provided a helpful manual accessible from the homepage with illustrated guides on how to access all our functionalities.
A little bit more about the technical aspects of our implementation. Our clothing scanner utilizes Google Cloud Vision API's OCR component to recognize the text on a clothing label, which we then pass to our custom keyword parser to determine the material and place of origin of an item of clothing. On our evaluation dataset of 32 clothing labels of varying origins and conditions, it achieved an accuracy of 92%. Though despite all this, we still offer the option to manually input the key data, especially if a keyword is not present on a single label.
A third-party library is used to recognize the dominant color of a clothing item. This color in the form of RGB is then classified into predetermined categories using the HSL model. This model organizes colors into a circle based on their hue. Red takes an angle of 0, followed by green at 120 degrees, and blue at 240 degrees. All other colors with angles that fall between these primary colors are a mixture of the colors. Bright and dark colors are differentiated based on the luminosity value. A low luminosity indicates a darker color, like black, while a high luminosity indicates a lighter color, like white. In the future, we could use a neural network with a softmax activation output layer to classify colors. In addition, color clashes can be mitigated by defining clashing or unappealing color combinations. For example, magenta and yellow, or red and green, or red and brown, as shown in the picture.
Our achievement system has been designed to easily allow new achievements to be added as our app grows. To do this, we add a new achievement type to the backend store, as well as add a mapping of the new achievement ID to the front-end achievement icon map. This can be a single image for one-time unlockable achievements, or a list of images for each achievement tier. With this, new achievements can easily be deployed to our app.
We will now show the dressing room and donation functionalities of our app from the perspective of an existing user. After logging in with Google, a user who has already used our app for a period of time would already have existing apparel items in their closet. When a user wants to look at their existing outfits, they can browse through them in the dressing room tab. The user can delete outfits like so. The user can also browse the closet and mix and match different clothing items to make an outfit. When they are satisfied with the outfit, they can then add the outfit to the dressing room. Additionally, if the user does not have any new ideas for outfits, they can generate random outfits to spice up their wardrobe by clicking on the dice button. As shown, multiple outfits are generated, and the user can add the ones that they like to their dressing room. As you may have noticed, your outfit generator does not match items with clashing colors together. For example, magenta and yellow is a clashing combination, and in all the outfits generated, this combination never appears.
When an item has not been worn for more than a month, these items show up in suggested donations. This prompts users to consider donating items that they have not worn in a while. As shown, this item was purchased in September and last worn in October, more than 3 months ago. We can donate individual items from this dashboard. This moves the item to the To Be Donated tab, indicating that these items are to be sent to the donation center at a later date. This action is reversible, and users can change their mind later regarding donating the clothing item. Users can also choose to donate items in bulk directly from suggested donations. The card shows the karma points the user stands to gain once they physically donate the item. No karma points are gained when items are marked as to be donated. When the user drops these selected clothing items off at a physical donation center, the user can then mark these items as donated. The corresponding karma points would then be added to the user's account. This action is irreversible. To encourage users to donate their items, our app also helps users find the closest clothing donation center to encourage users to bring these items to a nearby donation center. This tab brings the user to the Maps app to guide the user on directions to the closest donation store. Let's talk about the implementation of our closet backend. When an item of clothing is first added into the closet, as shown in the first demo, the clothing document is added to the closet collection. When the item is marked as to be donated, this document gets deleted from the closet sub-collection and gets added to the pending donations collection. The reason behind this design is to differentiate the items in a more clear-cut fashion. Instead of having to query on a field, the entire pending donations sub-collection is retrieved to get items pending donations. Similarly, when the action is undone, this clothing document gets put back in the closet collection, with a corresponding deletion in pending donations. Our backend is scalable since individual clothing item documents can easily be added to the collections in a NoSQL database.
Now, let's talk a little bit about our dressing room. As shown in the demo, we allow users to take advantage of our random clothing generator to put together outfits for them. We have a predetermined enum of valid outfit types, which include, for instance, dresses and tops and bottoms as the two main types. The presence of outerwear is subject to its availability. If the user doesn't have enough items to constitute a valid outfit, then we alert them that it's not possible to generate an outfit for them. We randomly pick the type of outfit, generate it using items in closet, and check for any color clashes within the clothing items. As you can see, certain color combinations, such as yellow and magenta, will not collate to form an outfit. The generator will only display a complete outfit void of any color clashes. We implemented this by looking at each clothing item's dominant color, which we detected during the scanning process and stored it in our backend. The user can continue refreshing to generate outfits until they find one they fancy.
Now, moving on to donations. When a user marks an item as to be donated, it's added to a To Donate collection in the backend. Every time we build our dressing room, we do a GET request that checks if clothing items are in the To Donate collection. If they are, all outfits containing the given item will be removed from the dressing room. As items marked for donation can be reversed, if a user decides they want to keep the item of clothing, the outfits that were removed to the dressing room can be returned. An outfit is only completely removed from the dressing room when it is deleted. We have also implemented a donation map for the users to show them the nearest places where they can donate their clothes. For this, we use Flutter's geolocator package to retrieve information about the user's location, and Google Maps Places API to find the nearest clothing donation centers to the users.
If you have reservations about our collection of your data, we assure you that we do not collect more data than is necessary for the operation of our application, such as location data in calculating karma values. Plus, you can opt to have your data deleted from our systems at any time, permanently, and with no strings attached.
For future improvements, we could offer users better suggestions for outfits, taking into consideration factors such as colors, styles, and occasions. Our karma points formula could also be more complex, making use of manufacturer and clothing brands data. And finally, we could also improve our gamifications aspect to engage our users more. And we can do this by implementing community leaderboards, events, and achievement notifications.
And with that, we conclude our presentation. Feel free to ask any questions you may have.